The most fundamental tool we have at our hands when it comes to analyzing harmony is the diatonic interval system, or just intervals. And this is a tool that enables us to describe the distances between all the stem notes and all the versions of the stem notes. That is the flats and sharps of the stem notes. So what it says is that while there are 12 different notes in an octave, we only need 7 different distance units. And these units are then defined by how many half steps they contain. And that might sound a little bit complex, but it's not all that bad. So just take a look at this note here. So let's say we play this note and then we play it again. We haven't moved at all. Then we say we have moved in unison. So that is no movement is called unison. If I move from this stem note to the next stem note, and this also applies if you move downwards, it's not dependent on which direction you move it. So if we move to the next stem note, we have moved a distance of a second. And then it's just numbers. This is a movement of a third, a fourth, a fifth, a sixth, a seventh, and then on 8 we have the octave, which is the same note. They are both called a C. So how do we know how many half step it is in each of these units? Well, we just analyze it using the keyboard. So if we are going to move from this note to this note, we are going to move a second. So if you take a look at that one on the keyboard, you see that the distance from here to here is 1, 2, 2 half steps. So we can thereby claim that a second is 2 half steps. But before we conclude that this is true, we need to verify it. So we try it at another place in the scale. So we try it here, and we move to this note, which is a motion of a second. And we find that this is also 1, 2. A second is still 2 half steps. But when we get to this note and move to this note, which also is a second, we see that there is no black key here, so we get just a half step. So this particular second here is just a half step. So what we end up with is 2 different versions of the second. We get a minor second, which is 1 half step, and we get a major second that is 2 half steps, or a whole step. And this will apply. You will find that if you do this analysis from all the different notes here, you will get only 2 versions. You will get it will be either a minor second or a major second. So we're gonna go on. We're gonna take a look at the third. So we're gonna move from here to there. So I'm gonna play them simultaneously to make it a little bit easier to see. So it's 1, 2, 3, and I add a note. So we got a third here. And we can count. We got 1 half step, 2, 3, 4. So a third is 4 half steps. This needs verification. So we move to this note here, and we add the third, 1, 2, 3, and we count 1, 2, 3 half steps. So this third here is just 3 half steps, while the first third was 4 half steps. So yet again, we get 2 versions of this interval. We get the minor third, which is 3 half steps, and the major third, which is 4 half steps. And if we continue the analysis, you will only get 2 versions, minor third and a major third. So we are now going to take a look at the fourth. So we just add a fourth from this note, 1, 2, 3, 4, like that. So we get that note, but it's moved there. So we count 1, 2, 3, 4, 5. So a fourth is 5 half steps. And we can go on, if we do this analysis with fourths, we will get on all steps except one step, we will get this fourth. That is 5 half step. We call that a perfect fourth. So a fourth is generally 5 half steps. But when we get to this step here, and we add a fourth, 1, 2, 3, 4, there, and analyze it, we find that 1, 2, 3, 4, 5, 6. There's one instance of the fourth that is 6 half step instead of 5 half step. And we call this fourth not a we don't talk about major and minor fourths, because generally fourths are just 5 half steps, so they are perfect. But in this case, we talk about an augmented fourth. And augmented is the same as sharpening. So what we say, we have a fourth where we've added yet another half step. So instead of 5 half steps, this particular fourth here is a 6 half step, which is an augmented fourth. So when it comes to fourth, we talk about perfect fourth, and we also got an augmented fourth. So we go back and we try to analyze the fifth. So we add 1, 2, 3, 4, 5, like that. We got a fifth, and we find that it's 1, 2, 3, 4, 5, 6, 7. And in the same manner as the fourth, on all steps but one, a fifth is 7 half steps. But we got one deviation from it, and that is if we move to this step here and add 1, 2, 3, 4, 5. So we got a fifth there. And if we analyze this one, we find that instead of 7 half step, we got 1, 2, 3, 4, 5, 6. So this fifth has been flattened or diminished, as it's called in interval theory. So, and just like the fourth, we talk about perfect fifths, and you got this one deviation that is called a diminished fifth. And then we can just go on and we can analyze the sixth, and we will find out that the sixth has a minor sixth and a major version. So, and it's the same thing goes for the seventh. You have a minor seventh and a major seventh. And I have written out the exact content in half steps in a PDF that you can try to learn, ideally by heart, but let's at least try to remember the concept that you have this. You have seconds, thirds, fourth, fifth, seconds, sixth, and seventh, and they are major and minor. And when it comes to fourth and fifth, fourths are perfect or augmented, and fifths are perfect or diminished. And that is the interval system.